Right, so in this question, part A, we're asked to calculate the time for accelerating this train, and we're told that it starts from rest. So in other words, the initial velocity is 0, okay? We're also told that it accelerates at a uniform rate of 0.4 meters per second squared. And then we're also told then it accelerates until it reaches a speed of 16 meters per second. So the final velocity will be 16 following this acceleration of 0.4. We're asked then to find the time taken, so we can use the simple equation of motion, okay, the v equals u plus at, okay, and we know v is 16, right, we know u is 0, we know a is 0.4, of course, and we're multiplying it then by the time, and all you need to do then, of course, is appreciate this is 0, so you just get 16 is 0.4t, so then 16 will be divided by 0.4 to get the time. Okay, so we'll use our calculator and we get out an answer of 40. So time is 40 seconds for this initial acceleration. Okay, part B then it says draw a sketch of the VT graph for the journey from A to B, right? So when it comes to, of course, your VT graph, first thing I'm going to do is a nice sort of size axis. Okay, remember this is a sketch, so we're not looking to get the scale perfect, but we want to get it looking as useful as possible. So we try and put the values in sort of the right places. Don't forget, the first thing I always do is label the axes, velocity then meters per second, okay, and time then in seconds. Okay. So this train starts at rest, okay, so at 0, okay, over here. And we're told that it accelerates for until it reaches a speed of 16. Okay, so maybe I'll put 16 here. And if we remember, it takes us 40 seconds to get to that speed of 16. So if I maybe put 40 seconds down here. Okay. So maybe we'll draw a broken line across here just to identify where our point needs to be for our curve. Broken line down to 40. So then my straight line then showing the acceleration from time equals 0 to time equals 40 seconds shows then the speed increasing to 16 meters per second. And if you want, I like sometimes to write the acceleration here just to show the rate it's accelerating at, which of course is the gradient of the line here. So it reaches the speed of 16. It says then it maintains this speed of 16 for t seconds. Okay, so for t seconds then, okay, it maintains this speed. So we don't know how many seconds that's for, but it's maintaining this speed. Okay, so we're going to have a line, horizontal line going across there. Okay, right, to show that it's staying at 16 meters per second. Okay, the acceleration is 0. Now, in terms of what we put down here, we have to be careful, right? Of course, it says it maintains the speed of 16 meters per second for t seconds. Okay, so this distance here, if you like, right, along the time axis is t. Yeah, you know, if you want, you can even sort of identify that on here as being t seconds. Yeah. But in terms of what we write down there, we need to appreciate, because we've got a scale here, we're actually, this t seconds started, isn't it, after the first 40 seconds, okay? So we need to add the t seconds on to 40 seconds. So here we're going to have 40 plus t, okay? That's what's going to go there. I don't know what t is, so that's the only way I can write that, okay? T seconds, it maintains the speed of 16 meters per second for, so we need to add that on to the first 40 seconds of that journey. It then says it decelerates uniformly to rest for 20 seconds. So we're going to have this going down to speed 0, okay, and that takes 20 seconds. Okay, so it goes from 16 then to 0 in 20 seconds. So if you think about it, if I got 40 plus t here, another 20 seconds here, well, if I add 20 on to 40, you get 60. So 60 plus the t, of course. Okay, so that should be clear there in terms of our scale, because this gap here is 20 seconds. right? Because that gap there is 20 seconds. Add that on to 40 plus t, you should get 60 plus t. So there's our VT graph, right? We can't do any more than that. We're done, and we got the marks, okay? So then it says part C, right? To find the value of t, okay? So we want to find t, but we need other information, of course. And the other information in this question is that it tells us the distance of the whole journey, okay? So the total distance is equal to 2,400 meters. And remember then, of course, distance is the area under the graph, right? Okay, area under this graph. So if we can work out the area under this graph, it obviously should equal 2,400. And I'm going to do that, okay? I'm going to do that here to determine the area. And we can look at this shape here, okay? We could split it up into triangle, rectangle, triangle, or we could think of it as a trapezium, okay? One large trapezium, which it is. So we could ignore these sort of broken lines here and see as a trapezium, where we've got this as our parallel side to this side here, okay? So the area under graph, and don't forget the area under the graph we know to be 2,400. Okay, that's important to recognize that the distance covered has been given, okay, to us. We're told that it's 2,400 meters, so that's what the area should be. Formula I'm going to use for area under graph is the trapezium formula. Okay, we can do all in one go, and we, as I said, keep going with this, right, expecting it to equal 2,400. So we have half. Now my A, well, we can take that top side as my A, which is just t. And then this bottom side then is the other parallel side, okay, is all of that there, that length, and of course that length is 60 plus t, isn't it? That's the total length of the time, for, up to there, 60 plus t. So that side there is 60 plus t, so that's what my B is, so put 60 plus t in here, okay? And then times it by then the h, the height between the two parallel sides, of course we know that's 16, don't we? Get that measure there. It's 2,400. So we just got a bit of maths now. In a way, we're working backwards on it because we've got the area already, we've got the answer already. We're working backwards to get t. Okay, so a number of ways you could do this. You could, right, work up the half times the 16. So you could do it in that order if you want. Okay, you might prefer to do that. Put the 16 at the front. Okay, because you times in them all. It doesn't matter what order you do it in. So put the 16 at the front of the bracket, and then in the bracket, then let's simplify that. You get 2t, don't you? Plus 60. Was 2,400. Half times 16 is 8. 2t plus 60. Now you could multiply through the bracket by 8. So you'd have 16t plus 480, I think, if you times through by 8. Or you could take that 8 over and divide. Maybe that's what I'll do. Because you're timesing 8 by that bracket. Take it over and divide by 8. So you get 2t plus 60 equals 2,400 divided by 8 is 300. You can check that on your calculator. Okay, so then perhaps I'll go up here just to finish this off. So then with an equation, then of course you take the 60 over the other side, take it away, right? So 2t is 240, and then t then, take the 2 over and divide by 2, you get 120 seconds. Okay, and we've worked out t.